Hello, kiddies. It's Kittyman74 here. In my previous lesson, right, we were talking about kinematics, and I feel I didn't cover it quite as well as I did because I wasn't thorough enough. So I was thinking maybe in this lesson we could just cover an additional question, which is a slightly different kind of a differentiation and integration, different kind of function too, and it involves integration. So previous lesson we only had something which involved only differentiation. Yes. So let's go here. Let's start. So this is our Kinematics 2, the second lesson for kinematics. And I think after this I should be done. I should have covered it quite thoroughly and you would know how to do most of the questions for kinematics already. So let's start off by reading the question. Reading is always the most important thing. Tell yourself that. Read and read again. So this particle moves in a straight line t seconds after leaving a fixed point O. So its velocity is given by this equation underlined here in black. Okay. So find an expression for the acceleration of the particle in terms of t and distance traveled before it comes to instantaneous rest. So we should think that this shouldn't be too difficult, but let's just take a look at it. So the velocity equation, right, part 1, we're given the velocity as this. So the easier way to think about this is actually to so-called linearize it, not really accurate term, but just writing it in the power -2 form like this instead of seeing it as a fraction. And then it should be easier to think about now. So now imagine now we just need the expression for acceleration, right? So a would just be equals to the derivative of velocity with respect to time. So here we're going to do bring down power -1, right? So 12 is still there. 12 is multiplied to the whole thing, so it doesn't disappear. Bring down power -1. Then we divide, when we want to integrate -3, right? It's 0. Because you're differentiating a constant, so it's just 0. So over here, we'll just get -24 over t plus 1 cubed. All right. So that's our expression for acceleration in terms of t, and that's already 2 marks. It shouldn't take us too long, but of course I try to explain as much as I can, so that's why it took a bit longer than I would have done if I didn't have to explain. Okay, so now distance. So let's just be clear. So let's handle the two parts separately. So it talks about distance and it talks about instantaneous rest. So the very first thing you should do is to check when the particle comes to an instantaneous rest. So when particle comes to instantaneous rest, right? Sorry, when particle comes to instantaneous rest, the velocity equals to 0. Always tell yourself that. So when we try to substitute in equal 0 to this, sorry, we equate it to 0, and then we try to solve it, right? So I'm going to skip a few steps here because by now you should be very good at doing this either mentally or slowing down and doing it by hand. But for me, I can just see this quite easily. So I add 3 on both sides, divide by 12, then I invert it. So this one will give me 4. Okay, if you need a few more steps to do this, just take your time. So what we need to know here is t plus 1 is actually plus minus 2. Remember when you're doing the square root on your own, right? You are the one saying that you need to do a square root. Then there is a plus minus. Okay? So t will be equals to -3, which is rejected, or t will be equals to 1. So please always write down both answers, then show your rejection. Or if you really want a reason for rejection, then this one isn't too easy, right? You're just going to say because time should be positive. I mean, this is not strictly necessary, but as for explanation's sake, right? I'm just trying to tell everyone how we should do this. Okay, so now we know when the particle comes to an instantaneous rest, right? T equals to 1. So now we want to find the distance. So over here, right, we know the relationship between displacement and distance, right? So S is the integral of from 2. Sorry, this question, right, actually is much faster if we do the definite integral. Yes. So the distance traveled by the particle, right, means it's implying that when the particle starts, the time is at 0, right? That's where this question all starts. When time equals to 0 until before it comes to an instantaneous rest, t equals to 1. So let's do this definite integral method. It's a lot faster. So now we are integrating velocity with respect to time. I say again, displacement is the integral of velocity with respect to time. So we have a 12 here, and now we're integrating this fella here. Minus 3 with respect to t. Okay, so now, as usual, so if you see this as t plus 1 to the power of negative 2, right? You simply need to remember that it's power plus 1 divided by new power. So power plus 1 will give us negative 1, and I need to divide it by the new power. So actually for this sort of integration, we still need to divide by the coefficient of t here, because we're integrating with respect to t. So you need to divide by negative 1, but over here dividing by negative 1 is still the same thing, so I just don't bother writing it. And then here we are going to have negative 3t. When I integrate a constant, and then I'll just get the negative 3t here. So from 0 to 1. So this one will give us negative 12 over t plus 1. So maybe just writing it again so it's clearer to see. So when I sub in 1, right, I will get negative 12 over 2, so it's negative 6 minus 3, subtract away. When I substitute in 0, right, it's negative 12 minus 0. Okay? So negative 9 plus 12, it gives us positive 3. So positive 3 lah, over here. Okay. So remember your concluding statement. Therefore, distance traveled by particle equals to 3 meters. Okay? So over here, just want to just reiterate this point, right? The advantage of doing this using the definite integral, right, over here, is because we don't need to have the the arbitrary constant plus c when we do the integration step, because the definite integral is already a definite thing, right? So we don't need to have this arbitrary constant plus c. Then you need to say, oh, when t equals to 0, the displacement equals to 0, because when t equals to 0, right, the particle starts at 0. So that's why you say s is equals to 0, then blah, blah, blah. You're going to say that you're going to have an arbitrary constant here. So I mean, just to be clear, right? So if you just do this integration, you're going to have a few more steps here. So then you have 12, negative 12 over t plus 1 minus 3t plus c. And you're going to say when t equals to 0, s equals to 0. So you're going to say 0 is equals to negative 12 plus c. C is actually positive 12. Okay? So did I make any mistake? Yeah, okay, this is correct. 0, negative 12. Yes, positive 12. Okay, good. So C is 12, which means your displacement equation, right, is actually this long looking thing, and you need to, you know, have another number to handle. So just be very clear what you're doing. My recommended way would, of course, be the definite integral method. Okay? So I hope this video has helped you, because previously I realized that I didn't cover the kinematics that well. And also some students, after doing a lot of integration and differentiation with complicated things like exponential functions, logarithmic functions, and trigonometric functions, right? But somehow they forgot how to integrate something as simple as this thing. You know, when you want to integrate this function, they suddenly forget how to integrate something like this. So I thought it's good to highlight in this video. So, well, if this video has helped you, please remember to like and subscribe and tell all your friends about this channel, okay? So, and as always, have a kitty nice day. Stay safe and work hard. Thank you.